examples in my book. Okay, so let us go to the next slide. Okay. First of all, let us recap some information about the feedback control system that you learned from previous week. Okay, so for the feedback control system as shown, so you are by now, you are all familiar with this control block diagram. So this is a feedback called a feedback control system where we have the input is US representing by U, and then the output is represented by Y, and then the system that we are investigating, the transfer function is represented by GS, and we have a feedback here. Usually it is from sensor, and the transfer function is given by HS, and then we put into the summation, and then we have some error here, and later on you will learn about putting the controller immediately after the error to reduce so that the error will be 0, hopefully. Yeah? Okay. So from the block diagram manipulations, you learn about how to reduce a block diagram of a few components of a systems into the basic control system, right? So this is the one common for a transfer function of a feedback control system, where we have, if we have a system like this, the transfer function, the output over the input will be GS over 1 plus GHS, where if it is in denominator and numerator, so the numerator will be represented by the upper fractions and the lower fraction is the denominator. If we have a transfer function like this, the characteristic equation is by setting the denominator of the closed loop transfer function into zeros. Okay, so by setting 1 plus GHS equal to 0, this is called characteristic equation. Okay, so this is the starting point. Okay, so you also learn that from different, from so many systems that you learn, mechanical system, electrical system. I'm not sure whether you did it with Dr. Fitri or Dr. Sanyos. So you have few system, electrical and mechanical. Most of the basics ones are electrical, the RLC circuit, and the mechanical, the spring mass damper system. So when you derive the equation for that system, you will come up with an equation of the transfer functions, which is represented by Y over U. The output over the input is numerator over denominator. So where you have Bm S power m plus Bm minus 1 Sm power S to the power of m minus 1 plus triple dot plus B naught for the numerator. And for the denominator, you have S to the power of n plus A n minus 1 S to the power of n minus 1 plus triple dot plus A naught. Okay, if we can represent this into poles and zeros. So the YS over US is actually the top one is for the numerator and the bottom one is for the denominator. And numerator is zeros. The roots are called zeros, and for the denominator, the roots are called poles. Okay, so these are the basics that you learn. Hopefully, you remember. Okay, from the previous week. Okay, so because we're going to deal a lot of poles and zeros while sketching our root locus diagram. Okay. Okay, again, another recap. Okay, so now that we have gain K, so our transfer function for this one is KGS. Okay, the others are all the same as previous block diagram. So I need you, I'll give you a few minutes, 2 to 3 minutes. Okay, for this feedback control system, find the equation for the first one, closed loop transfer function. Second one, open loop transfer function. And then third one, characteristic equations. And then finally, what do the roots of the characteristic equation represent? Boleh? Cuba. Okay, try to derive the closed loop. Dah buat dah pun tadi kat depan. Transfer function. Open loop transfer function macam mana? Characteristic equation apa dia? And what do the roots of the characteristic equation represent? Anyone ada nak jawab? Class? Okay, the first one, closed loop transfer function. Apa dia? Closed loop transfer function is YS over US for, ni you all buat masa block diagram manipulation, right? For this type of feedback control system, the closed loop transfer function will be, apa dia kelas? Hello?
KGS over 1 plus KGS.
HS lah. Kita ada HS dalam ni Betul? Okay. So what about open loop transfer function? Siapa dia open loop transfer function? Open loop transfer function will be, kita timeskan KG dengan
KGS dengan HS total.
Yes, good. KG HS. So this is the open loop transfer functions. What about characteristic equations? Previous slide. Characteristic equation adalah this one, and we equate it into zeros. So the characteristic equation will be 1 plus KGHS equal to zeros. Okay. What the roots of the characteristic equation represents? So tadi kita kata apa? Bila kita dapat Y over S, U over S is actually numerator over denominator. Okay. So seems that the characteristic equation representing the denominator. So the roots is actually telling us about the poles of the system. Okay, ada soalan? So this is the solution. Any questions so far? So for today classes is 1 hour. Since it is 1 hour, most of the time will be on understanding the concept. And then later on, lepas ni baru onwards, we will start sketching the root locus diagram. Okay. So hopefully these are the things that you really have to understand to move further to root locus diagram. Okay. So now let us go to root locus. The learning outcomes will be, after completing this section, students should be able to, so at the end of the section on this root locus, you will be able to sketch the root locus diagram of a system and then show mathematically how the location of the poles change as the design parameters is varied from 0 to infinity, especially for a second order system, and utilize the magnitude and angle criteria, especially on design. Okay, so let us understand the concept of the root locus first. Okay, so we have a feedback control system as shown in this figure. Okay, so this is the input represented by US, output YS, okay, and then we have controller K, and then this is the transfer function of the system. Definitely it is a second order system because it is S squared plus 2S. Okay, so now let us look how the roots of the characteristic equation change. Okay, the roots apa tadi? Yang ni lah. the poles. The roots of the characteristic equation change as parameter k changes from 0 to infinity. So when we, later on, when we're going to do the controller design kat sini, bahagian di sini, we will always deal with the value of k. By changing of k, what happened to the system? So these are the things that we will learn later on. So before we proceed with that, let us understand the concept of root locus. So this is the, now is, I'm showing you, I'm sharing with you what happened when we change k from 0 to infinity. What happened to the roots of the system? Okay, so kalau yang ini, can you all determine the characteristic equation of the system, class? What is the characteristic equation of the system? Closed loop transfer function lah, okay? So determine the closed loop, saya tulis closed loop C. Okay, closed loop transfer function will be YS over US. Okay, macam mana buat closed loop transfer function? So kalau sistem macam ni, apakah closed loop transfer function, class?
K over S plus K plus 2.
K over?
S multiplied by S plus 2.
S plus 2. Dah.
Equal to 0.
No, I need the closed loop transfer function first. Macam ni betul ke? What about others? You belajar block diagram manipulation kan last time?
Plus K at the denominator.
Plus K. Betul? Macam mana dapat macam itu? Okay, kalau kita buat slow-slow lah So if I do it one by one, yang cara lambat punya. So Y over S over U over S equal to KG. KG tu 1 over SS plus 2 over 1 plus KG lah. Okay, K S S plus 2. So you simplify, you akan dapat this one. Sama lah. Okay, so bila kita dapat closed loop transfer functions, so now we want to look at the characteristic equation. Yang mana satu characteristic equation? This one. So this is the characteristic equation. Lepas tu kita equatekan dengan 0. Okay, so until now semua boleh ikut kan?
Boleh, Doktor.
Boleh.
Okay, so I proceed. Okay. So kalau kita tengok tadi, kita punya characteristic equation, the green one, S square plus 2S plus K equal to 0. Okay, so we go back, go front. So S square plus 2S plus K equal to 0. So we know that the denominator representing poles. Okay, so kita nak cari dia punya roots. We want to find the value of poles. So we use this equation lah. Jadi dia akan ada S1 and S2. Okay, ni macam mana dapatnya? Kita guna formula. Minus B plus minus square root. Apa dia, kelas? B square.
Minus 4AC.
Yes, dengan 2B. So kita apply this equation. So kita akan dapat this one lah. Minus 2 minus B plus minus B square 4 minus 4A 1 CK over 2B. 2B ke 2A kelas? 2A kan? Saya pun dah lupa ni. 2A ke 2B? Kalau 2B dapat, aduh salah. Sekejap
Wait, betul.
Itulah, macam mana nak padam sekejap, tak apalah. 2A. Okay. Okay, so because it is squared, maknanya kita patutnya ada dua roots lah. So we will have S1 and S2. Okay. The concept of root locus tadi, kita nak tengok what happened to the poles bila K tu from 0 to infinity. Yeah. Okay, so let us increase our K slowly. We start with 0. Okay. So what happened when K equal to 0 to this value of poles? Okay, jadi bila kita solvekan these problems, kita akan dapati dia akan dapat bila K equal to 0, square root 4 is equal to 2. So it will be minus 2, okay, plus 2 dengan, and then divide by 2 sini, dengan minus 2 divide by 2. Okay, so S kita akan ada S1, 0, S2, minus 2. Okay, so I put it here. Okay, if you look at the the right hand side, so ada dua S roots tu, I differentiate with green and red. Okay, so green will be the S1, red will be the S2. Okay, so when K equal to 0, so this is our first S1, which is at 0, and then this is our S2, which is minus 2. So now let us move when K equal to 0.5. Okay, when K equal to 0.5, we put it here, and the poles will be minus, the S1 will be minus 0.29. So katakanlah dekat sini is minus 0.29. And then the second one yang ni is actually minus 1.7. Okay, and then increase lagi. So now K equal to 1. The poles are, bila kita letak sini, kita akan dapati the value of S1 and S2 both akan pergi kepada, will equal to minus 1. Okay, so that's why if you look here at a real axis, X equal to minus 1, we have both colors, green and red. Okay, and then I proceed with K equal to 2. Now the poles are, so this is where S1B, Allah merah pula. Okay. So this is S1 and this is S2. Okay. So kalau kita tengok sini, the first one will be minus 1 plus J, which is here. Sini sebab imaginary axis. Minus J. Okay. So, kalau kita tengok di sini, this is the pattern, the pattern of what happened when K, we start to increase the K. So, for the first poles, dia akan start daripada 0, and then dia pergi sini, and then finally dia akan pergi ke atas. The green one, semua nampak And then this is what happened to the second one. Dia start dengan minus 2, and then dia pergi ke sini, and akhirnya dia pergi ke bawah. As K increases, dia akan pergi kepada infinity. Okay, so this is what happened to the system when we increase the K, because where is the S? Where is the poles? So poles ni indicate the location of the system, and I think you've learned about stability before this. Okay, kita boleh tahu region, adakah the system is stable or not based on region di mana kan? I think you've learned previously on the topic of stability. Okay, so this is the concept of root locus. We're going to look at what happened to the poles, to the roots of the system as we increase the value of K. Because K, kalau kita tengok tadi, they represent this K is actually represent the controller, control system. Sebab kalau kita buat control block diagram control system, this is the transfer function of a system. Tak kisahlah sistem apa, electrical ke, spring mass damper system ke, gear ke, and so forth. So all this kat sini adalah controller, because bila kita masukkan feedback di sini, we will have error, and this controller kita akan manipulate dia supaya the error will be reduced, okay, and the system goes on lah. Jadi kalau kita ada sensor, so this one will be our feedback. Okay. Understand class so far? So far so good? Senyap tu good lah.
Okay, Doktor.
Yes, Doctor.
Fokus, Doktor, fokus.
Okay, so I proceed. Okay, observation. This is the most important one. Observation. Saya dah terpadam lah Pak. Saya tak tahu macam mana nak fikir balik. Ada betul tu. Okay. Mana tadi? Okay, so this is the observation. Kalau you all tengok tadi, the loci starts at open loop poles for k equal to 0. Jadi kalau kita tengok the previous slide, okay, kalau kita tengok previous slide, so like this, we have two S just now, S1 and S2. So the locus when k equal to 0, dia akan start pada poles of that system. Okay. Let's say kita tak ada k di sini. So our characteristic will be S square plus 2S equal to 0. So S plus 2 equal to 0. So kita punya poles, open loop poles adalah kejap sensitive. Okay. So open loop poles kita adalah first S equal to 0, and then the second one yang ni S minus 2. Jadi kalau kita tengok on the observations, the loci start as open loop. Open loop ni bila k equal to 0 tadi, open loop poles for k equal to 0 and terminates at open loop k equal to infinity. Jadi kalau kita tengok tadi, dia bergerak ke daripada 0 and minus 2, and then dia bertemu pada satu point, and dia akan pergi kepada infinity. So the general transfer function yang kita buat tadi, and the loop transfer, the open loop transfer function adalah KGHS yang ni kita buat lah, which is actually the K, the value of K ataupun gain times NS numerator over denominator. The numerator akan menghasilkan atau akan give us about information about the zeros, and the denominator is poles. Okay, so therefore the closed loop poles are the roots of the characteristic equation 1 plus GHS. Jadi kalau kita tengok tadi, 1 plus GHS is actually the closed loop poles. So when k equal to 0, the characteristic equation becomes the denominator equal to 0. When k equal to infinity, the characteristic becomes numerator equal to 0. Okay, oops. So, sekejap. Sensitif sikit lah saya punya ni. Kenapa dia tak mau kat ni? Okay, let us go further. Ada satu lagi konsep, angle and magnitude criteria. This one kita akan pergi masa when we did the root locus design later. Tapi saya kena mention because we are dealing with the characteristic equation sekarang. Okay, so all poles must fulfill the angle and magnitude criteria dalam this characteristic equation 1 plus KGHS equal to 0. So bila kita ada 1 plus KGHS equal to 0, therefore the K and the GHS equal to minus 1. Jadi bila kita buat root locus, two condition must be satisfied by every point of the root locus. The first one, the magnitude of KGHS must equal to 1. Okay, and the angle, angle is given by this one, this argument of K and S tolak dengan argument K DS, numerator minus denominator. Kita akan lihat contoh selepas ni. Okay. Okay, so let's say this one we have open block diagram macam gini. Okay, so this one dia punya feedback is unity. Okay, so we have the open loop transfer function, the KGHS is given by this equation. So we have S dengan times S plus 1, S plus 2. So lebih kurang je macam yang tadi, tinggal lagi dekat atas kita ada zeros. Okay. Okay, now find the closed loop transfer function of the system class. Okay, saya bagi 2 minit boleh? Dapatkan closed loop transfer function, because from this closed loop transfer function kita nak tengok characteristic equation. Apa dia? Closed loop transfer function, which is ys over us. This one is given by k s plus 1 s plus 2.
Doctor, is everything okay, Doctor?
Yeah?
Is everything okay, Doctor?
Yes, yes. Why?
Tak, Doctor, dengar bunyi jatuh. Ingat laptop Doctor jatuh.
Saya punya pen. iPad pen. Okay, dah semua dah dapat closed loop transfer function. Okay, diam je ni. Dapat ke tak dapat ni? So I assume you all equation derivation ni sepatutnya dapat dah mahir dah ni. Okay, so you all buat macam biasa ataupun kita akan dapat dia punya short form dia adalah numerator K S plus 1. Denominator dia adalah yang denominator plus the numerator. Okay, so kita ada S plus 2 plus K S plus 1. So dia akan dapat K S plus 1. So kita ada 2 sini, S1 S square. And then untuk S kita ada 2 lah. Yang ni S times 2, this one. 2S dengan KS. So 2 plus K S. And then this one akan plus K. Okay, semua orang dapat closed loop transfer function begini?
Dapat.
Okay. Dapat tak?
I have a
So-
question.
Ya?
It says here KGSHS equal to KS plus 1 S multiplied by S plus 2, but here it's not. It's like is it supposed to be KGSHS or KG only? Because there's it's very confusing here.
KGHS.
Yes, because in the left it says KGS equal to KS plus 1 over S multiplied by S plus 2, but here it says KG only. So there's a bit of contradiction there.
Because because our H is in unity.
Because it's 1.
Yes.
Okay.
Okay. Any other question, class? Okay, boleh. Okay. So this is our the closed loop transfer function. Ys over us. So ni dia. I put it in green color, this one. Okay. So therefore the characteristic equation will be setting the denominator equal to 0. S squared plus 2 plus k s plus k equal to 0. Okay, now the same concept as previously. We want to look how the poles locations varies as k varies. Okay, so up until now, class boleh follow ke? So far so good?
Yes, Doctor, we're following.
Okay, so I proceed. Okay, so this is the closed loop transfer functions, ks plus 1 over, we have the denominator open loop tadi, and then plus the numerator. So therefore the characteristic equation is s squared plus 2 plus k s plus k equal to 0. So again, we want to find the roots, which is in this case the poles. So since it is a second order system, so we're going to have two poles here, S1 and S2. Okay, so minus b plus minus b square minus 4ac over 2a. Again, okay. So let us again look now when k equal to 0 and k equal to infinity. So bila kita, when we put k equal to 0 here, okay, the poles are, since it will have two poles, so the first one, S1 will be 0, S2 will be minus 2 here. So this is S1, this is S2. What happened when k equal to infinity? Okay, so when k equal to infinity, we put that k infinity into this equation, the values of poles. So when k equal to infinity, we will get two values. One is minus 1. Okay, so this S1, when k increase, it will stop at minus 1. Okay, so the second one, the minus 2, if we increase k to infinity, so it will goes to infinity. So this one, minus infinity. Okay, so I put a note here. Cross is for open loop poles, circle is open loop zeros. Because last time we have here, okay, kalau kita tak ada k, if we don't have the k, so our first one, s plus 1 is our zeros, and the second one is s plus 2, okay, which is our open loop. That's why it calls it's open loop poles, open loop poles, open loop zeros. Okay, jadi kita ada S1 kat sini poles, the poles S1 and S2. Then we have zeros is actually this one representing the zeros, which is Z1 equal to minus 1. Yang ni lah. Okay, so the conclusion that we can make from this is that for a root locus, yang kita buat ni sebenarnya, the one that we did actually is drawing the root locus initially, tapi root locus later on there are 9 steps. I shared with you the root locus steps in e-learning. Later on we will look into it. So the root loci and open loop zeros, which is at minus 1, and implied zeros, which is minus and negative. Sebab in this case we have two root locus. Okay, the first one I differentiate it with color green. The second one is I differentiate it with color red. Macam mana saya tahu, how do I know that there are two root locus? Based on the number of poles. So dalam case ini, since it is a second order system, so we will have two poles. Okay, so therefore our root locus will be 2. Okay, the first one, yang green one, what we can conclude is that for root locus, it will always start at poles. Dia akan start dekat poles, open loop poles. So macam ni kita ada dua poles, 0 dengan -2. So this is the starting point. Okay, and then kat mana dia berhenti bila k itu, when k equal to infinity, where will it stops? Okay, so if there is a 0, macam dalam case ini ada 0, open loop zeros, so one of the root locus will end at zeros. Okay, so this one, since dia dekat sini, dia akan habis di sini, stop. So that is the root locus. So itu position kita punya roots lah when k increase. So it's still in the stability region, for example. Okay, and then kalau kita lihat untuk the second case, dia akan pergi kepada infinity. Okay, so dia satu saja poles dalam case ini. So satu akan berhenti kepada poles, satu lagi 0, satu lagi pergi ke infinity. So this is the conclusion that we can get. So the number of root locus will depend on the number of poles. So dalam case ini ada two poles, therefore our root locus ada 2. One is the green one. So this is first root locus and this is the second root locus. 1 and 2 depends on number of poles. Okay, so if we have a zeros, one of the root locus will end at zeros. Inilah zeros, dia panggil ni zeros. Yang ni. Okay, setakat ni faham? Any question? Okay.
No, Doctor, all okay.
Okay. The last one will be on using angle and magnitude criteria. Show that one of the roots of the characteristic equation for the control system with following open loop transfer function. So let's say we have open loop transfer function k over s squared plus 4s plus 6, and given that k equal to 4, and in this case our system is the third order system. Okay, so we put the s into the equation. So we have, finally we have this equation. So our kghs will be 4 over -1 plus j, 2 plus 2j equal to 1. Okay, so this is the first characteristic just now when I mentioned about angle and magnitude characteristic. Okay, so what does it mean here? Actually, what it means is that if s minus 1 plus j is a root of the characteristic equation, yang inilah, -1, katakan this one is -1, this one is j. So S1 adalah kita punya roots. So if we look into these equations, so poles of the open loop transfer function, memang kalau equation yang ini dia ada dua lah, because this one ini kita panggil complex poles. Okay, so kalau s square plus 4s plus 6 ni equal to 0, so kita akan dapat S2, S3 equal to -2 plus minus j 1.414. This one ni kita guna yang equation tadi lah. Dalam case ni kita ada 3 because here, macam nak padam okay. Kat bawah ni so we have s square plus 4s plus 6. Okay, so sebab dia s to the power 3, so kita ada 3 poles kat sini lah. The first pole will be s equal to 0. Okay, so yang ini adalah the second and third poles. Okay, so maksud dia dengan angle characteristic is that sudut dia must be equal to 180 degrees. So how do we calculate the angle? Okay, so this is the roots. Angle tu dia selalu mesti starting from 0 kat sini kepada to the line. So this is our S1, This is our S2. So this is our S3. Okay, sebab S1, S2 kita adalah -2 plus minus J1 here, 1.414. Okay, so if we want to check whether the roots dia memenuhi the criteria number 2, which is that the summation of angle must be 180 degrees. So kita cari sudut. So this one, angle 2 and angle 3. So kalau kita pakai compass ataupun we can calculate actually when we know the locations, we can calculate the theta 1, theta 2 and theta 3, and it should be 180 degrees. This is the concept that of angle and magnitude criteria. So the angle must be 180 degrees. What about the magnitude? Okay, magnitude maksud dia di sini the magnitude of KGHS will be 4. D1, D2, D3 is actually the length of this one. D1, D2, D3. These are all you will learn when we do the design later on. Tapi ni yang saya nak tunjuk kat sini adalah the concept of angle and magnitude criteria. So how do you do that? Okay, so the angle will be always calculating from 0 kat sini ke mana dia pergi to the point. Katakan kita nak buat design satu point, let's say S1 is one of the design point. Jadi bila kita nak check dia punya angle, it must always refer from the poles and zeros to that point. Okay, kita kena panjangkan line dia lah. And then when what about the magnitude? Magnitude will always be the length, length di sini. So this is the S1 tadi, S equal to 0. So this is the length. Okay, untuk poles yang kedua, ni poles yang kedua, poles yang ketiga. So this is the length, D2. Ni poles yang ketiga, this is the length, D3. Okay, so this is the concept of angle and magnitude that I mentioned earlier. Angle. Okay, the angle, dia mesti konsep dia yang ini. The summation of angle equal to 180 degrees. The magnitude, dia mesti always 1. Okay. Okay, we have few minutes more. Let us look. Okay, saya stop dulu. Let us go to our e-learning. Can you see anything, class? Not yet.
Nothing, Doctor. Just can see normal, Doctor.
Okay. I will share. Kalau saya nak share. Cancel. Window. Apalah saya nak share sini. Okay, so let us look at our notes here. Okay, so that today class is actually on the concept. If you look at the notes here, you nampak ke apa yang saya share sekarang?
Nampak, Doctor, nampak.
Okay, so if you look, one of the notes that I put there in the e-learning is on root locus step-by-step procedures, how to do the root locus. Yang tadi saya buat konsep dia sahaja dulu. Okay, starting point, kenapa dia start dekat poles, kenapa dia end dekat zeros dan sebagainya, so that you understand the concept of root locus. Okay, and how to do that, you have to find the open loop transfer function, get the characteristic equation, blah 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 and so forth. So for Friday's class, we're going to draw the root locus, which by following this step by step. So I start with the basic concept of a control system. So you must understand K, G, H, and then the closed loop transfer function, the open loop transfer function, and the characteristic equation. These three things, you have to understand that. Okay, in order for you to draw, let's say we have a system like this, we want to draw or to sketch the root locus of the system. So we know that what happened when K kita varies lah from 0 to certain point. So these are the steps. Saya ada basically 9 steps. Okay, 9 lah sampai sini. Okay, where the last one, kalau kita tengok secara general dululah, so maknanya you have to determine the poles, you have to determine the zeros, this daripada open loop transfer functions. And then kita kena start draw dia dekat imaginary and real axis. Okay, put the poles, put the zeros and all that. Selalunya poles kita represent by cross, zeros kita represent by circle. And then kat sini di sini yang kita punya konsep tadi. They always start at K equal to 0, dia akan start dekat poles. Dekat mana dia berhenti? Dia akan berhenti sama ada infinity ataupun zeros tadi kita buat. And then how many root locus that we're going to have? It depends of number of poles. Jadi kalau third order system maknanya kita ada 3 poles. Kalau second order system kita ada 2 poles. So 2 root locus. And then kita akan belajar about asymptotes, and then center of asymptotes, then breakaway point, and then for complex zeros and poles yang ada J, kita akan learn about dipanggil apa? Angle of departure, and then you will use the last topic that you learn from Dr. Sanius on Root-Hurwitz criteria. From there, kita akan gunakan this Root-Hurwitz criteria to determine the value of T dan sebagainya ni lah dalam transient. Transient response kita jumpa kan value-value ni.